Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Right, I'm going to do a review video on this thing. This is from Banggood, so thank you very much Banggood for sending this to me. It's at no charge for the purpose of review, so I got this for free. Usual disclaimer. Let's see what we got. So we got like some ex-factory date, serial number card thing, quality certificate, which hasn't been filled out, which isn't a great start. Okay. So we've got some this in here. We've got some leads. So you've got a USB, IEC cable, which is no good to me because it's got the wrong kind of plug on it. A BNC cable and a BNC declock lead cable. Markings on this are SYV50, so I'm guessing that means 50 ohm, most likely will be. This one here is the same marking. They both got exactly the same markings, but they're not the same cables, I don't think, because this one seems thicker than this one. They're not the same cables. Interesting. Anyway, and we got obviously the standard USB. Nothing particularly exciting about that. Okay. Let's get to the unit. So, what have you sent me? Here we go. DDS signal generator and counter. 100 to 240 volts. That must be switch mode. Obviously, well, it weighs nothing, so yeah, it'll be switch mode. One of it's got an internal fuse, unlike the Wellers. I should actually have a look, shouldn't I? So we got trigger, FSK, ASK, PSK in. Interesting. Sync out, sync in, and a VCO. Interesting. And it's got a TTO output as well. A manual came with this. Got a power cable plugged in. Let's turn the power on. This is at well, currently seeing 221 volts because I'm just running for variac, but yeah, close enough. Should be fine on that. And no smoke. Let's see if I can turn it on. Oh, switch on the back. Turn it on too. Here we go. Little display there. That boots up really quickly. That's nice. It's got a kind of typical Chinese display where it's just a rather, well, I don't know, basic font set, I suppose you could say. So frequency, amplification, offset, duty, phase. Okay, so that's how you change each one of those. Get a little dial here, which is actually a bit stiff. That knob's a bit small for that, really. It's in kilohertz. Mind your decimal point now, so I'll say it's 10 kilohertz. So, okay, well, it's got a counter as well. Let's try to get this angle right so you can see the bloody display. So it's got a frequency counter, which should be that input there. I suppose we can check that for accuracy and stuff. Tells you duty cycle and stuff like that as well. AC-DC coupling. Gating, gate times, obviously for accuracy. Zeroing, wonder what we want there. I suppose if you're doing counting rather than frequency counting. Start, stop. Frequency and count, yeah, okay. So if you want to count pulses, you can do it too quite easily. VCO. I have to look into this, see what this actually does. Amplitude, offset, duty, frequency. Linear or start end. Linear logarithmic. Forward and backwards. A manual would have been really nice to come with this, but there wasn't one. user guide download, feeltech.net. There we go. Alright, so I have to download it from there in order to get the manual. So I might have to do that and actually find out what that VCO mode does. System save loading, so you can save setups, looks like, or configurations. Synchronization, so you synchronize two channels together, it looks like. Configuration English, yeah, buzzer on, so you can turn the beeping on and off. Uplink off, uplink on. I guess that means you can send data to master slaves. That means you can link more than one unit together. Interesting. Sweep functions, so you can do sweep between frequencies for a period of time. Modulation types, so you've got FSK, ASK, PSK, burst, AM, FM, PM, which is phase modulation. Source, channel 2 or manual. Hops, yeah, I don't know what those are. And channel 1 sine wave stuff, so amplitudes, frequency, yep. Parameters there. Sources for the actual, so channel 2, manual, external AC, external DC. The options there. So in other words, you can set up on channel 2, you can set modulation type on that, and you feed that in this modulation on channel 1 internally, it looks like. I mean, use FM modulation, you can put, you know, put 1 kilohertz on output 2 and have something else in that one. I'm not sure what the top frequency is on this thing. It's 250 mega samples a second apparently. Okay. Screw wave. So the wave types. You've got lots of wave types here. Wow. So it's actually got arbitrary waveforms in it as well. Do that way. Arbitrary or sine wave, there we go. So we can change the types. That's channel 1 settings, that's channel 2 settings there. If you want to move the cursor, we can use that. In fact, it says kilohertz there, I'm guessing that's kilohertz, that's megahertz. So how high can we go with this? 60. Let's hook up the output onto something and we'll try it out. Okay, so you can see I've got it set up to my scope here and I'm just playing around with it. Now I did actually find a bug with it before. I haven't replicated it again yet, where I'd play around with the offsets so that you had a DC offset on the waveform so I could shift it up and down, and even though I'd set it back to 0, it was still offset. I haven't been able to recreate that though, so it's also a little bug in there somewhere, so it's something to watch out for if you do get one of these. So maybe there could be a problem with that. So right now I've got it set at 1 kilohertz on a sine wave. My scope here is saying 1 kilohertz with a sine wave. Alright, it's looking like a fairly reasonable output on there. Being DDS, it actually looks quite nice. Okay, so this does actually do 60 megahertz. Alright, so my scope can also display 60 megahertz. Let's go up to 60. And my scope can just do it. Alright, so there's 60 megahertz there. Alright, but the actual output does drop in magnitude. Okay, so as you increase in frequency, the output is dropping. So it says it's 5 volt amplitude. I'm actually getting 3 volts peak to peak. So it's not 100% accurate in that way. So if we wind it back down, you can see the waveform increasing. It's now 4 volts peak to peak of 40 megahertz. So it's 30 megahertz getting about 4.5 volts peak to peak. 20 megahertz is 5 volts peak to peak. Alright, so basically 20 megahertz really is kind of the top end. I'll go down in 1 megahertz steps. 23, 22. 22 is kind of there. Alright, so basically 20 megahertz. Up to 20 megahertz, you got an accurate output waveform as far as the amplitude goes. You have to watch out for the amplitude dropping off. But I mean, that's not bad though. In fact, you know, it does pretty much flat until 20 megahertz. Isn't that bad in itself? These aren't particularly expensive units. As I want it down, it's still going alright. So you've got the modulation one as well. That does actually work. I'll just have to remember to use it. Not to use it once. So it's got to set 1 megahertz with the modulation set at 90% on AM. Okay. There's a way of turning this thing on and off. I can't remember what it was. I've forgotten. I did it before. It's not 100% obvious. It's made a 10 megahertz waveform, like so. Hope you can see it on screen okay. This looks a bit dim actually. There you go, that's better. So modulation. There we go. It's kind of doing something now. 1 megahertz. So let's just bring this down and try and get that to actually. See, it needs to lock on there. Just to adjust my triggering. Just to hold off, I should be able to get it to lock on. If my trigger position's in the right place. There we go. Alright, so there's the waveform there. Alright, AM waveform. So as you can see, it's coming out okay. That's for 90% waveform. If I adjust that parameter there, you can actually do up to 200% modulation, which is quite interesting. But as I bring it up to nearly 100%, I don't know where you can see that on screen, but 99%, that basically is 100% wave modulation, right? And 99. Do 100%, it's actually over modulating very slightly. It's got a little bit of a flat line there. Right, so it's actually a little bit too much. I'd say sort of 99 point, probably about 99.6 is 100% modulation. It looks like it's very slightly out, going by that. Okay, not a big deal, but it works nice enough. Right, so so you just AM modulation. This is when you see I'm over modulating, it's doing 130%, and go right up to 200%. And that's when it's time. It's kind of sort of unlocks and goes a bit crappy on the triggering there. Alright, but very interesting. So then we've got sweep functions as well. So this is currently set from 1 kHz to 10 kHz. So let's just slow this down a little bit somewhere. And natural channels have got LEDs behind. We can't see it because of my lighting, but these buttons do actually light up. So you can see which channel the channel's turned on or not. So channel 1 on. It's interesting getting the waveform coming out because there shouldn't be anything coming out right now. I'll turn that off. So there shouldn't be anything there. No, there shouldn't be anything there. It's got some little quirks in there about the user interface, which just doesn't necessarily work quite the way you'd expect. This is now doing a 10 megahertz signal, which is what I want. I want 10 kilohertz. This is on standard waveform stuff, so I should be able to get that easy enough. So yeah, 10 kilohertz on there, alright. We go to the sweep function, and you start and stop sweep by pushing that button there. So I've got it sweeping between 1 kHz and 10 kHz right now. So there you go, it's sweeping just fine. And you've got different options. You've got obviously start frequency, stop frequency, the time for the sweep, linear logarithmic sweeping, and you've got direction as well. We can actually set this as fourth, so you go forwards, so you increase the frequency and starts again. Alright. Or you can go backwards, so it reduces in frequency. Right, and again starts again, or back to fourth, or fourth to back as it says. Alright, so it sweeps up and down. Alright, and you use the OK button to start these functions. So that works okay. So the system, we got these other functions here, synchronization and more. What's in more? You can set the defaults to on or off when you're booting it up, and you can also reset the factory defaults. Now this thing actually is quite interesting way that if you turn it on or off, it's instantly off, right, like that, as you'd expect. But also, it's instantly on as well. Right, so it's like in a standby mode. It isn't actually truly off. If you get, like I had that quirk on it where the offset played up, and I had a DC offset on the signal, even though I had it set to 0 volts, and I actually had reset the power on the back there, on that power switch on the back, in order to correct that, because turning the soft power didn't work. So let's just look at the offset side of it again. So if I set on, 2 volts offset, I'm getting 2 volts offset on the scope there, right? And I go -2 volts offset. It can go like -10, I think, plus or minus 10 volts, and then I got -2 volts on there as well. Right, but it's around this sort of time I put it back to 0, and I was doing something else, and it kind of got confused. And let's change it to square wave. And the offset somehow got stuck on there. I don't know how, and I don't actually know what I did wrong there, or how to even recreate it. So let's look at its square waves. So this lead is obviously not calibrated. This is the 50 ohm lead straight into the scope, so it's not even me holding the lead, it's getting noise, picking up lead, noise in the lead and stuff like that. So it's not a great waveform on there. How much of that is because of the lead? How much of it is my probing technique? With this particular lead, there's no 50 ohm load on it, so that's going to be affecting it as well. Should be tee off, put a 50 ohm load in there, or something like that to load that down, which might clean it up a bit. But so you can pretty much take that as it is. So square wave, CMOS, whatever that is, adjusted poles. It's got all these different waveforms in there. On each type, and you just go through them with that dial. Arbitrary waveforms is like 64, so I think you can program it with software as well. It does a lot of. It is an arbitrary waveform generator as well. You just have to know how to figure it out and use it. So well, that works fine. This VCO section I haven't looked at yet properly, so I think it's actually waiting for a voltage on the back. So maybe you input a voltage, it will adjust the frequency. That's what a voltage controlled oscillator is, after all. So I think that's what it's waiting for, as an input on the back there from the VCO signal. And frequency counter, we haven't looked at it yet. Let's try it out. Now I've got my rubidium already turned on, and that should be locked. Yes, it is. So I'll chuck a precise 10 MHz frequency into it. With a precise 10 MHz reference from a rubidium, we'll set fluctuating very slightly, currently about 5 Hz out. I've seen it out to about 15 Hz out. Make of that what you will. Accuracy wise, that isn't actually that bad, really, if you're only using it for like a general reference. There you go, so you can see cycle, wide, so it's obviously like the plus and minus ratio, like the duty cycle, effectively. I'm showing it there anyway. Interestingly, it's not actually showing a 50% waveform as far as duty cycle. It may not be, I don't know, it's rubidium, who knows what it's putting out. I mean, it's sine wave, but yeah. Gate time's on 1 second, so let's increase that gate time. Which one was the second button there? Let's do 10-second gate time. And see how that improves the accuracy at all. It should do. Should give a more, well, at least more accurate count. There we go. Alright, so I think this is about 8.3 Hz out, which isn't really that bad, for what it is. It's not specifically meant to be a counter, really. I mean, obviously it does that function, but you can pay a lot more for counters and have less accuracy than that out the box, Alright, maximum safe input voltage is 10 volts AC and DC. Alright, a little warning down here, you probably can't see it too well because of the lighting. in the angle of the screen, but it's 5 volts DC AC input voltage maximum. So it's a little warning on there to remind you, so you can't take a huge amount of input voltage. I think this is only doing about that anyway. There you go, it's down to 4.3 Hz now. So there is some fluctuation in the counts. I do know that my rubidium does do weird stuff. It does put out glitchy, it will do like a runt pulse on the frequency, so sometimes it will read randomly, a bit weird like it did just then. And my other counters do it, it's normal. I'm used to seeing it on my rubidium, so but that looks close to right. So function wise it seems reasonable. So I thought I'd show you the waveform output at the maximum frequency. So let's bring it over here and set this up in maximum frequency. So 60 MHz output, and get triggering, and there's the waveform. Let's just do this auto scale thing. Becomes a bit nicer. Jitter wise, actually looks okay, and that sort of stuff. It all looks fine. So this is my scope going as quickly as it can. Right, that's 5 nanoseconds of division. You can see maybe there's a little bit of jitter in there. The cursor's jumping around very slightly, so maybe a little bit of jitter in that signal, because it is DDS, don't forget, so there could be a little bit of glitch there, but it's 14-bit DAC. But usually when you got low resolution DDS, you can actually see steps in the waveforms. I'm not seeing that at all. I'm not seeing any kind of steps. If I reduce that waveform amplitude there quite a bit, you can actually see maybe here there's jittering. You know, maybe it's less clear in that way. So there could be a little bit of jitter in there, but it's not much. Okay, so I'll just turn off my light here to try and give you a better view of the screens in case it really does show up a lot better. I think it actually does make it look a lot better. I mean, it all works okay. Obviously it's got some little quirks in there where things don't seem to like turn on or whatever they are. I'm really not sure, but I hope you can see those LEDs on there now. See that lights up? It's actually going to look warm on there, so I'll actually open it up soon and have a look. So how do I get this thing to turn on the waveform modulation? So there's the whole thing there of trying to get the modulation to actually turn on. It's not on right now. It's almost acting like there is modulation, but I'm not seeing it. I'm only seeing the waveform itself dipping down, not seeing modulation coming in. So there's some kind of little quirk there where it doesn't quite work the way you expect it to. Odd. That's really all I can say, is it odd? The modulation does work, but let's just reboot it. So let's boot back up to 10 kHz. That's not what I want to do, is it? So let's go modulation mode, channel 1 frequency. I don't want 10 kHz. I want 10 MHz. Okay. And I want AM modulation. 50%. Now the AM modulation, I want 1 kHz AM modulation. Maybe that's the issue I'm missing there. Channel 2 sine wave, 10 kHz, let's go. 1 kHz modulation. I've got modulation now. So maybe that's the little thing I'm missing there, is having to go into channel 2 and set the modulation level up on there, then go back in again. I don't know, maybe that's what I'm missing, but now there's modulation. The scope's not triggering not very well, but it's there. I don't know, it's just some weird thing. It's just that part, if you're using modulation, I mean obviously it works, but it's a little bit glitchy. I suppose I could actually hook this up to my modulation meter and see what that thinks of it. Could do that, couldn't we? Let's fire that up. Here is my Boonton modulation meter. And it's currently saying we've got 32.2% modulation. This is set to 50%. So, Does that mean that's not accurate? Maybe. So let's look at the parameter setting. Let's go got 10% at the time, let's do 60, 70, so if I do 100%, which I know on my scope looked 100%, here we go here. So maybe my waveforms aren't perfect or something, or the input level's a bit high or low. Yeah, I've got quite a high IF level on there. So maybe the output's a bit too high for it. Let's just reduce the output. Maybe that's causing some problems. Here we go. Right, so 100% on here is basically 100% on there. I'm not 100% sure of the accuracy of this thing because it's something I've repaired in the past. So let's just drop it down. Oh, go to the right setting. It's 90. See, this is looking a bit odd here. Do 20%. Saying 10. I don't know. I'm not sure if I trust this or this. I think I'll probably trust this more. 50% on the scope did look a little bit low. Can you trust it? Yeah, maybe. Okay, well, let's open this thing up. We've had a look at how it functions. Let's see what's inside it. It has been getting warm. I can feel it's warmed up a bit. Oh, this is tedious. More power. Well, maybe less power. Alright. Faster. Maybe. So it's just screwed into plastic, but you kind of expect that anyway. It's only case screws. It's not like something you have to open up all the time. Just try and see how to actually pop this cover off. It's like it's hooked in there somehow. Here we go. Right. There's some manual focus still. I think it is. Let's just fix that, hopefully. Just put it back off the tripod onto here. So there's a heat sink on here, which is actually fairly warm. So obviously got a switch on my power supply right there. The earth wire goes to there, onto that plug. Not to there, which is cut off. That's interesting. Does that mean these are floating relative to earth? That might be a good thing. Let's have a look. So it's just check resistance from the earth pin. Yeah, it's one of those. No, it's got 2 ohms there, so less than 9. Let's try and get a decent connection. 0.6 or so, yeah, that's alright, because 0.6 is basically what my probes are. Alright, so yeah, straight through. So they are indeed grounded. Must have a secondary cable or something goes through. So those are indeed grounded terminals. Are they grounded to each other? Let's just use bloody sounder, it's easier. Yep. Yep. So it's all grounded to each other. So the switch obviously goes straight to that board there. It's got a little fuse right there. Discrete diode rectifier. These connections on the back, I'll just check the earthing on those too, shouldn't I? What are those relative to? Are those relative to ground as well? Come on. Oh, put on the right thing, be helpful. Yep. So they're all grounded as well on the back panel. So that may or may not be a good thing, it depends on what you're doing, but generally I always assume the metal shields are connected to the ground anyway, that's why I assume them to be. And those are all grounded, so okay. What capacitors in that? Say Sunicon cap. Yeah, Sunicon. 105 degree rated though, so yeah. Other caps, what are they? JWCO? Yeah, budget caps. But that little heatsink there is getting pretty warm. And it looks like a sort of screw through it. It does, it's got a screw through the middle of it. So that must be the output transistors underneath that. Well, output MOSFETs, most likely. So that's obviously what's cooling those down. I'd be inclined to beef it up a little bit. You know, I don't like things getting hot. It may or may not matter, but yeah. So these light voltage regulators in the back here, I guess. Reference crystal. Some trimmers here for various adjustments. Can't see them being marked for anything in particular. Just adjustment markings. It's Altera FPGA, Cyclone 4. So, some relays on there for each output. I mean, it actually looks quite tidy. It looks like quite a nice little board in there. It does look nice enough. Rear panel, so we've got a buzzer on there, and it's got a little cover over it still. So if you want to make it louder, you can peel that sticker off and make it louder. Also there's a flex there going to the LCD, and there's a crystal there for that display controller. It looks okay. I really, I wouldn't really be worried about it. I think that looks fine. You know, you got various qualities, and that board looks like it's reasonably made. I'm actually quite surprised. It looks reasonable. Yeah, they're proud enough to put their name on it. It's got Feeltech.net on there. So they're proud enough of the board and the circuitry to put their name on it, which in itself is a good sign. It's not like a non-branded thing. It is truly theirs. Feels like there's options behind here. I can feel cutouts on the panel, or maybe there's different options. Yeah, you can see kind of something there. Maybe it's displays, something, LEDs or something like that. But power supply is obviously a generic third-party branded one, which they've fitted around it. I don't know why I've done that little cutout on that board. That's a bit weird. I suppose I could have turned it sideways, but yeah, I don't know. Let's pull this power supply board out because it's the most suspicious thing, and we'll have a look at the other side and see what the oscillation's like. So obviously isolation on bits of test gear is quite important. Don't want to have something to go wrong. So 3 screws holding it in. That's alright, I suppose. Just like it's getting jolted around. It's got a nice isolation gap down there. That's not bad. There's no slot, but it does have a gap in the traces. Auto isolator there. So yeah, well, I'm not worried by that. I think it's fine. I'm not great at switching my supplies, so I can't really analyse it too closely, but this is all the switching side here. Low voltage conversion to drop that down for that regulator there, that switching controller for the chip, which will be driving that coil, which then puts out the low voltage side. So, and the feedback's done by the opto isolator there. Maybe it's a couple of opto coupler would be, not an isolator, I don't know, it could be either way. But that just feeds back what the output voltage is, and but there's an isolation gap there between the traces, so yeah, I think it's okay. There's no input protection as such, there's no signs of like MOVs or anything in there, but yeah, it's not likely to need it really. It's a nicety in this sort of gear. It's not like it's a multimeter where you need it on the input section to protect the input because you don't know what you're going to be getting on it. Whereas this is, fixed main supply coming in. So also you've got a little transformer down here, which is dropping down actually. That's what you're using, a little transformer, not capacitor. Yeah, it's got the USB port and the TTO input there, which is obviously linked up to this chip here, whatever that is, going to the FPGA. I think it's quite nice. I reckon it's worth buying. It's got obviously some firmware glitches in there. But as it's USB, it might be possible to upgrade the firmware in it anyway. It might be possible to do that. And get the cover back on again. It's quite a tight fit. Come on, in you go. Right. There you go, it's all in. No, it's nice. Little tilting barrel in there, I should mention that, shouldn't I? So, it's okay. You know, this is, the casing feels a little cheap, but you know, it's okay. We've got, you know, they've got the rubber feet on here too, which the cheaper units certainly won't have. That sort of little details like that just helps to reinforce that the brand is putting a little bit of effort in. Could do for due charge, I think. Right. So I really need to find a manual for this thing and see where this is. So TTO out's got TX RX 5 volt 0 volt old ground, it says. So it'll obviously run out to the back. So you have to be careful that shorting these pins there, because you've got a 5 volt and 0 volt there. If you short those there, it might cause some damage. So here you go, VCO in. That's what I wasn't paying attention to, is in, not out. So that's how you control the VCO sweep function on that thing, or the frequency sweeping. I think it's okay. I don't mind it. I should go and check the price. I don't know what it is offhand. I'll go and check the price, see what it is. So I've gone to the Feeltech website. I'm downloading the I think that's right. Downloading the user manual for it now. So the mixture on the website, even if you select English, it still shows a lot of Chinese on the page, but there is English there. So I'm downloading the manual now, and we'll see how that comes out. But I think this is actually not a bad little unit. This is the, say, this FY6800 60M, so I'm guessing 60M is 60 megahertz. Thank you very much, Banggood, for sending this to me for free. Thank you very much. And links will be down below for you to go and look at this unit on Banggood and to purchase it if you're interested in one. I still need to go and find the price. I'll be right back. Right, this is currently on special right now, 13% off. So it's usually $207 New Zealand. That's currently 182 New Zealand instead. US dollars, it's about 50% more New Zealand dollars. So my maths in my top of my head is probably $120 or something like that, US. Be around that kind of value. If you're starting out and you want something which is quite fairly accurate, looks like it's fairly configurable. You know, the fact it has modulation stuff on it as well, and you can do up to 60 megahertz, means you can actually maybe use this for doing radio work. You might be able to, you know, chuck a 26, 27 megahertz signal out of it and AM modulation and tune a radio with it. If the modulation levels are accurate enough, I might have to re-look into that into more detail. I might chuck it on something else and do some analysis, or even back onto my scope and do some calculations. I could even do it on there, because that should be able to tell me. But yeah, it's not bad. Right, so I thought I'd just try this out using my CB over here as a receiver. So I've got it set to 26.330 megahertz, which is a channel 1 frequency for that radio sitting over there. And you can hear it's got like a buzz, right? That's the DDS noise. Right. So it's the DDS. It's not perfectly stable. There's noise coming through with that DDS signal. So if I turn modulation on, you can hear distortion in it as well. It's not perfect. So unfortunately it's not really suitable for that kind of work. It is hard to get a kind of DDS signal which isn't noisy like that, because they are made out of pulses. So having lots of pulses means you're going to have noise. You know, it's a pretty good waveform if you looked on the scope. You know, it looked nice on the scope, but your ears are much more sensitive than that, and you can hear it. And that humming is a sign of the pulses on DDS and affecting the VCO frequency, stuff like that on the DDS. So that's just one of the symptoms of using a DDS system, which is why they're generally not suitable for radio stuff. But depends on what you're doing with it for. You know, it might be adequate for what you're using it for. Thanks, Banker, for sending it to me. Much appreciated. Focus, you bugger. Focus. Oh, you're kidding me. Yeah, focused. Damn bloody thing. So hard to get decent camera gear.